I'm going to present emerging technologies for EV charging with grid infrastructure. As this EV act as battery in case of renewable energy resources, and we can get the energy from EVs as well as we can fed back the uh, energy from EVs to the microgrid. So let's discuss about this interesting topic, EV charging. So here we have coming by why we are going to EVs. If we see on the global level, then we can see that in last 3 years, from 2019 to 2021, the emergence from uh, commercial vehicles to these EVs, the growth is very fast. If, in 2019, the sales of EVs is less comparison to 2021, but this fall in sales of EVs is due to the COVID only, but the increment in 2021 is significantly high in comparison to 19 and 20. Why the growth of scaling of EV is come in global level just because of the limited number of the limited amount of conventional resources. Those are feeding the vehicles. So here we can see the first graph that is related to the global sales of EVs. The comparison is monthly, January to December, and the light blue color graph is showing the sales of EVs. This is in 2019, and the last graph is this last graph is 2021. Okay, so here this is the global level, but if we talk about India, the major problem here in India is the pollution. Our more metro cities are at the top level of the in the pollution. If we talk about Delhi, the capital of India, it is having pollution, and the significant amount is due to the transportation. Okay, so this is the major problem in India, due to which we are moving from conventional vehicles to the electric vehicles. Okay, we can see that the major amount of pollution is due to industries, and the second level of pollution is due to the vehicles only. That's why we are moving from conventional vehicles to electric vehicles. And we are trying that these electric vehicles should also be of complete green in nature, means these should be fed by some renewable energy resources only. So we are adopting the renewable energy resources like solar panels to charge these vehicles. So we are adopting the technologies, those having the solar panels, pins, to make the charging stations. We are trying to install the renewable energy resources only on these stations. So here we can see the unit sale, the last graph, the below one graph is the sales in India. Here we can see there is an interesting scenario here. We can see that in 2015 to 2021, here we can see that three-wheelers are mostly running on the roads. The sales of three-wheelers are most in 2015 than 2016, and this level is significant up to 2020. Okay, in comparison to all other vehicles. Uh, if we see after 2015, in 2016, there is started two-wheelers. Those are based on the electric technology. So these two-wheelers are running on the roads today also. And in 2017, this amount is increasing. But if we see about the four-wheelers, means cars, the amount is very less. Okay, but this amount is come in picture in 2020 and 21 in India only. So here, this is the graph for that one. And all other vehicles are buses and e-rickshaw. These type of things are and other things. And this graph that is BEV and PHV sales and their percentage growth. And we can see here country-wise growth of these vehicles. We can see that the most of the sales are in China. Okay, because these are more populated country, most populated country is China. So they are covered with very high pollution also. So the sales are, as soon as the electric vehicles are coming picture, the sale is very high in these countries, China, North America, and European countries. And our India is coming the other countries, which is having very less amount of sale in EVs because of the lack of transfer of technologies only. So there is a high scope of research and project development in this area, especially in our country. There is lots of need to do more and more research in the EVs also, electric vehicles also, as well as in the charging technologies also. We have some advantages also. These vehicles having very lower maintenance, but the initial cost of these electric vehicles is very high. If we see in India, these vehicles having high cost due to the arrangement of the battery, due to the battery size only, due to the battery technology. The the initial amount of these vehicles is very high, but these having lower maintenance cost, these having electronic devices only. So if there is some fault or some protection issue occur in the vehicle, then just by replacing the small portion, small device from the vehicle, we can maintain the vehicle. Okay, so running cost is very less in this case, and these are very simple to control. Suppose we have some issue with the controlling system in this. So just by changing a converter or a one controller, we can maintain it. So just we can change the algorithm, we can feed the program in the controller, or we can change the program of the controller to maintain the vehicle. And environmental foods, these vehicles are coming picture just due to environmental condition, lack of conventional fuels available, and these vehicles produces very less amount of carbon emission. This carbon emission is just due to the presence of battery only. Okay, and if we replace these batteries with hydrogen cells, then this amount will get zero only. And what are the limitations why we are not going to these electric vehicles? There are some limitations like charging stations. Those are not these are not permanent limitations. These are just temporary. We can increase the amount of charging station. We can deploy number of charging stations at different locations. So this is a temporary limitation. This is not permanent. And range of range of distance is also an issue. This is also a temporary problem, not permanent. The technologies are developing. So there is lots of scope for the researchers and engineers to do work in those to increase the range of distances in the vehicles and temperature control of the battery also. And what about energy efficiency? These are very energy efficient. As we are adopting the renewable energy resources, the number of energy conversion stages will get reduced. If we use renewable energy resources to charge the electric vehicles, to adopt these technologies in charging on the charging stations, we can reduce the number of conversion stages. So energy efficiency will improve of the charging of electric vehicles. So let's see what are the type of EVs that we have available. So broadly, we can categorize them: battery electric vehicles, plug-in electric vehicles, and hybrid electric vehicles. There may be some confusion between hybrid electric vehicles and plug-in hybrid vehicles. So let's see what about battery electric vehicles. As it means, it is battery electric vehicles means this is completely depend upon the battery only. Once battery, it can be the battery has been charged, it is inside the electric vehicle. So these are only based on the battery. There is no another compartment for the for other fuels, just like petrol or some other gases. So there is only one partition only for the battery. So these vehicles having the large size of battery bank, and their range depends upon the size of and the type of different type of vehicles, type of size of battery and different type of vehicle. And we are, because there is no other type of option to charge these vehicles, to drive these vehicles, so we have to charge the batteries in a significant amount. And uh, all vehicles try to maintain the driving range of this 75 to 402 miles, depending upon the type of vehicle, company of the vehicle. Because this time electric vehicles are completely based on the manufacturer, which company are manufacturing these vehicles, all having different technologies. But the tentative amount is 75 to 400 miles. These vehicles have to go 75 to 400 miles. Once they are fully charged. Okay, examples of these type of BBs are Tesla. Tesla is number one in this, and Chevrolet, Nissan Leaf, etc. Okay, there are different models, as I'm saying. The all models having their own ports. Tesla mode having its own port. We can't use different connector to this Tesla. Tesla having its own connector. And if we talk about hybrid plug-in vehicle, plug-in hybrid vehicle, which is mostly used, it is having two compartments. One for the battery, we can charge it for the supply or the charger, and another one we have the option of the fuel also, other fuel also. So the range for these electric vehicles is about 10 to 40 miles, because we have option to again drive the vehicle with the help of other fuel that is available here. So we have both the two compartments here, and we can see here we have two chargers, one electric charger and one is we have petrol uh, fuel compartment available. So this is also hybrid in the sense that we have electric battery also and we have fuel also. These type of vehicles, these are different from hybrid electric vehicles. How these are different, I will tell you. And example of these type of vehicles are Chevrolet Volt, Toyota plug-in, and Kia Optima plug-in. Their name are ending with plug-in only. And unlike hybrid electric vehicle, these can recharge at AC level 2. AC level 2 means those we are available at our home or on the petrol pumps. So the electric vehicles, those are installed on the petrol pumps. Okay, and these cannot be recharged on the DC fast charger. DC fast chargers are for the battery electric vehicles only, because these need to be charged very fast and having the higher area of the battery compartment. Now, third is the hybrid electric vehicle. This hybrid electric vehicle having battery but not plug-in. This is also having two compartments, one for the battery and one for the fuel. We can fed the fuel from the external source, but we can't charge the battery. Charge itself installed in that vehicle, and it is once charged, it is installed in it, and then it will be charged by the other fuel. Okay. So this is the difference between plug-in hybrid vehicle and hybrid vehicle only. The plug-in hybrid vehicle can be charged with the charger, but these hybrid vehicles don't have any option to charge with the level 2 charger or DC fast charger. Okay. But they are having the battery. Now, as I told, that different type of manufacturers has designed different technologies, and they having their different chargers. Suppose we are in India and we are going to charge our mobile. Then these ports, those are available here. The we can these are of different types. If we'll go to US, then the charging ports are different. Same case here in electric vehicles also. The electric vehicle companies are from various countries, and as our electrical system is different to other countries, so they have their different charging ports. That's why different charging connectors available here for electric vehicles, and we can categorize them as DC fast charging and level 2 charging. If we talk about DC fast charging connectors, these are of four types. These are of three types. Shedemo. Uh, this is Japan-based company. Shedemo means charge and move. So this is Japan-based company. The all electric vehicles, those are designed by Japanese technology, having the connector like Shedemo. And another one is CCS. These are adopted by US and European countries. And Tesla is different. Tesla cannot be charged by any other connector, whether we are adapter or no. It is having their own charger. And level 2 charging is for like our homes. We can charge it from our the supply. It will take one or 10 to 12 hours to charge a battery, to charge an electric vehicle. As I told about connectors, there are the availability of adapters. Suppose you are charging your laptops, so you need to connect the adapter. An adapter you have to connect it. But in case of electric vehicles, we need to avoid these adapters because this is an additional electronic device and this will interrupt the security of the electric vehicle protection system. That's us, we are generally avoid this, but sometimes we need to connect to charge our vehicle with some other chargers which is not compatible to our electric vehicle. So in that case, we need the adapter, which can change one type of electrical board uh, parameters to other type of electric chargeable parameters. So here are some approvals of the adapters. There are three adapters according to the charge connectors. Like one is level 2 AC adapter. It can be used for L2 J1772 low level charging. And the second one is CCL12 Tesla adapter. Suppose we have Tesla card and we have the charging station available only for CCS. Then in that case, we can use this adapter, CCS1 to Tesla adapter. And third one is Shedemo to Tesla adapter. Because Tesla is difficult to find here in India, but it is going to sell and install deploy the charging station in India. It is in process to deploy its charging stations. Now, common failures to adopt use these adapters are common mistake is to misapply the Tesla AC adapter to DC charging connector. In that case, what will happen? The complete circuitry may be damaged because all electric vehicles having electronic circuitry, electrical circuitry, if a small fault occurs and complete circuitry, complete board may be damaged. Like in case of battery electric vehicles, there is an inbuilt onboard charger. So that inbuilt onboard charger, if a small fault occurs, it can be damaged completely. So here we are interested in the electrical and electronic units of electric vehicles, less in mechanical part of these electric vehicles because mechanical part is same like in our conventional vehicles. Here this is assembly, this is the mechanical part, and battery motor, this power control unit, this is our main concern. Electric vehicle structure having wheels and other circuitry. So here, what is going to charge our electric vehicle is the charging station, and this charging station having the direct connection to the onboard charger. As I told that in case of DC charger, AC charger available we have, then in that case we have onboard charger in the vehicle. Why this onboard charger required? Because this onboard charger having capability to convert that AC voltage to the DC voltage. Okay, that's why this onboard charger having different units of converter stages, and here this inverter part available that is used to convert DC to AC sometimes, and we have motor and battery pack. So how the electric vehicle works? Suppose a driver here, we have driver, it is giving command in the form of expression when a control signal is generated and this control signal is transferred to the motor control unit. Here in this motor control unit, we have the connection to the motor as well as the battery. Okay, so battery in this control unit, battery gives the fuel to drive the electric vehicle. Now, these are some mathematical part, uh, how the electric vehicles are moving with different forces. So, if we see the total power that driving the electric vehicle, it is equal to the total tractive power multiplied by the this velocity of its velocity, FTEV. This FT is total tractive power. This is the composition of different forces, including rolling resistance force and aerodynamic force, hill climbing force, linear acceleration force, and angular acceleration force. These all forces are combinedly making the total tractive force for this vehicle. Then this rolling the now we can see different forces. We can see how these forces are helping to drive the electric vehicle. Rolling resistance force, as it means, is rolling resistance. That means it is related to the wheels. Rolling means this is related to the wheels, and it is equal to rolling resistance constant multiplied by mass of the vehicle. Heavy or light, it depends totally upon that, and gravitational acceleration constant also. Okay. The aerodynamic drag force, it depends upon the type of environment in which we are driving the car. It depends upon the air density and frontal area of the car, its bonnet area, and drag coefficient, velocity of the vehicle, and another force is hill climbing force. Okay. On which surface we are moving the car, it depends upon that one, and it is equal to the mass of the uh, vehicle and gravitational force and the angle that is made from the um, that it is made from the horizontal plane. And we have linear acceleration force. It is ma simply mass and acceleration. And angular acceleration, it depends upon the moment of inertia, gear ratio, acceleration. Here the gears will come in picture in this force. And radius of the tire also, and efficiency of this momentum. This is the architecture of the power flow of electric vehicle. Here we have electric vehicle control propulsion system. In electric propulsion system, we have electric vehicle controller, electronic power converter, electric motor, mechanical transmission system between the wheels. And electric vehicle controller, in this we have energy management unit and electronic power converter having energy source which is connected with the energy refueling unit also. And we have some auxiliary power supply, and here we have power steering unit which getting the command from the steering wheel. So here we have different chargings, EV charging, different level of EV charging. So we have fast charging, that is DC charging, and AC charging. AC charging having level 1 and level 2 charging. So AC level 1 charging, those are this type of charging at our residential areas. And these charging are of 120 to 230 volt AC and having 12 ampere to 60 ampere, and these can be worked on single phase supply. But it takes lots of time, around 24 hours or 20 plus hours will take. And level 2 charging, if we talk about level 2 charging, these are also AC charging, and these are in commercial areas. We can say that if you at your university, we can park our vehicle in the morning and we can take it back in the evening. Okay, and it will take around 5 to 6 hours. Or these type of charging stations can be installed in the restaurant area where we can charge our vehicle for a time when we are getting our food or we are going to shop something. And DC charging station level 3, that is fast charging chargers. These will take only 15 to 45 minutes depending upon the uh, onboard charger installed in the electric vehicle. And the third part is, this last part is vehicle to grid or grid to vehicle. If we are connecting direct grid, our vehicle to the grid, and then we can also on the off time of grid, we can supply to the grid from the vehicle. See, this is different type of thing here. Now, we can compare these AC versus DC charging stations, or the charging, how these are different, AC and DC charging. So, main component of electric vehicle is electric motor. How the electric motor is working depending upon the supply. Okay. So, if we talk about DC charger, if we have DC charger, there is no need to convert the type of power. We have DC power and we are driving we have to charge the DC component only, that is battery. But if we have AC supply, we have AC charger, then in case of AC charger, what we have to do, we have to we need to conversion units. We need to convert the AC to DC. Okay, so let's see here some differences of AC charging and DC charging. In case of AC charging, what we need a onboard charger in the vehicle. Why? Because AC chargers are giving the only AC supply to the vehicle. So we have the onboard charger in the vehicle, which automatically convert that AC supply to the DC power before feeding that power to the battery. Okay, because battery can only adopt the DC power. So these AC charging vehicles charge the vehicles, those are charging on the AC supply having the onboard charger. Now, if we talk about DC charging, these are giving directly DC power to the battery. Okay, the onboard charger is available only in the charging station. There is no need to have an onboard charger on the vehicle. And AC charging, these are a very common mode of charging because their cost of installation is very less. But in case of DC chargers, the cost is very high because on board charger we have to apply in the charging station only. That's why the cost is very high. Another advantage of the DC charging, the fast charging station, these are charging in a very fast speed because conversion stages are very less, and we can have the installation of renewable energy sources on the DC charging stations is very easy, and these DC charging stations lead to the charging stations on the green side, green infrastructure. Now, these AC chargers having of type 1 and type 2, as I told, type 1 are of residential type, which takes 20 plus hours to charge, and type 2 are the commercial type, which takes more than 10 plus hours or to complete charge the vehicles. And these AC chargers are cost effective because they chargers don't require the conversion units, and these are available easy, means the infrastructure of charging AC charging stations are easily available, and we can charge at our home also. As I told, that type 1 charger is residential type, and this installation is very simple. Their charging rate is continuous, but the disadvantage of these AC chargers are the slow charging. This is the major drawback. If you have time, then you can charge on AC chargers. Otherwise, you need to, if you are moving on the highways, then you need a fast charger only. It depends upon your requirement. That's what type of charger you require. So we can see here what is the difference, pictorial difference of AC charger and DC charger. If we see on the side of AC charging, in this type we need an onboard charger in the vehicle, so that to convert the AC power to the DC before going to the battery. While in case of DC fast charging station, the power is going directly to the battery. There is no need to have an onboard charger on the vehicle. That's why we are moving towards the DC fast charging stations, whether they are costly or not. Why? Because the bulkiness of the vehicle can be reduced if we have DC fast charging stations, and more and more consumers can be attracted because they don't have worry about the charging of the vehicle. Here we can see the charging curve of AC charging station and DC charging station, and we can see here in case of AC charging station, here the battery state of charge, it is charging up to a level, and then there is a continuous charging of the battery. But in case of DC charging, we are saying this fast charging. So it charged at a very fast speed, and the curve is going fall very uh, steeply. So in what we have, as we are saying that AC charging system at present, we have AC charging stations are more. So what we need the onboard charging system. So what the things are going on the onboard charger system is we are converting the AC power from an external charging DC voltage. Okay, so here we have this, we have uh, power factor control unit also, we have DC to DC switching here, and we have full bridge rectifier filter. These much circuitry we require only in our vehicles only. So if we talk about the power factor control, this power factor controller is very necessary to be in charging board. If it will get, it is not uh, about to unit, then in that case, the more and more fluctuations are there. Battery is degraded because the ripple factors are more in that case. This is the fast charging station output, the curve of fast charging. This is the output DC voltage of fast charging system, and this is current. And here we can see the battery terminal voltage. This is having high data, that's why there are fluctuations. And here we have battery charging current and battery SoC. And the main concern is, our concern is on battery SoC. The battery SoC describes how much fast the battery is charging. Okay. So this sudden increase in the battery SoC is showing that the charger is a fast charger. Okay. Now, how long it take to charge your electric vehicle? There are many parameters, and first of all, we are discussing about the electric parameters because these are electric vehicles. So let's first concern on the electric parameters, how they are affecting the charging speed, or how they contribute to charge the electric vehicle. Okay, you can take an example of a water tap. Okay, so you are opening the tap and water is flowing from the tap. So how much the pressure is there? According to the pressure, the amount of water will flow, and output is also according to that, the pressure of the water. So here, this voltage works like that. Higher the voltage, high amount of current. Current depends upon the area. Okay, how much area available to spread the ions for ionization. And then according to the voltage and current, the power will get, okay, from the charger. Suppose we having the high voltage here, and the current is also according to that, wider area we have available, then power is more. Okay. So it depends completely upon the voltage and current. So it is voltage, as in simple words, everyone knows that this is the potential of energy. And it applies on higher voltage means each bit of electricity can provide more power. Okay, suppose I'm saying 24 volt I have. Okay, and I have 48 volt. So 48 will contribute more. Or 24 to 25. If we're moving 24 to 25, we are seeing just only 1 volt difference, but it will contribute a load in the power. Okay. And amperes is current. It is the flow of electrons through conductor. So size of conductor, larger the area, larger amount of high amount of current we have. So it depends upon the area of the charger, the cables that we have seen. Now power, the combination of this volt and ampere, we get the power. Okay. So as we can see, I have written water pipe pressure by ampere. We can compare it, and the flow rate as the water. Now energy is, we have kilowatts as the power, and if we talk in terms of time, time matters in case of DC charging stations, because I am saying if I am talking about level 1 charger, it takes how much time, and level 2 charger कितना time वो ले रहा है. According to that, we have the energy. How much energy transferred in case of level 1 and level 2 charger and the fast charging station. Okay. Now, the another main component is SoC, state of charge, and it depends completely on the manufacturing of the battery. Okay. The state of charge, how much the battery is full. Okay, and at what amount the battery can be full. If I have a good type of battery, then its SoC is high. If SoC is high, that means it is charging with a very fast speed. Okay. It depends upon voltage, current, power, and SoC. Now, charging speed. Sometimes what happens that we have charging station, we have the one charging station suppose, and I have one vehicle. I'm going to charge this. So my vehicle takes some other like 6 hours to charge. Then my friend will come and he is going to charge his vehicle. Then it will take 8 hours to charge. So what effect is charging speed? Okay, same vehicle, same charging station, but there may be some technology inside the vehicle which are affecting the charging speed of the vehicle. So first is the type of vehicle. Vehicle means when a battery is more depleted, the charging speed is very typically faster. Means if it is there is no space of ions, it is completely drained. Then in that case, the battery will charge with a high speed because it is having because ions do not have to seek this space to charge where they have to fix. So charging speed is high. But as soon as this battery will get charged, then the amount of charging speed will get less. Okay. Uh, Next is charging system. Which type of charger we are using? So different electric vehicles having different capacities for charging speed, charging station also having different capacity. As I'm told, it depends upon vehicle. It also depends upon the different type of charging station capacity. They are having different capacities, having maximum rate of charging threshold, which decides the capability to charge a vehicle. For example, we have here an example. If we have a 50-watt capable EV, it cannot be charged any fast at 350 kilowatt station. Why? Because maybe the charging station not having capability to charge that vehicle in a proper way. That's why it will affect the speed of the charging of electric vehicle. Now, one interesting thing is outside temperature. Outside temperature is also affect the charging speed. And why? If we have the normal temperature, normal weather, means there is no heat, no significant heat or cold, then the battery will work in normal mode. But high heat and the uh, lower temperature level will affect the charging speed of the vehicle batteries. So again, the battery generate heat whenever it is going to charge because of the movement of the ions. Nothing is going on in the battery, it's just movement of the ions. Okay, so during this movement, due to this movement, what will happen? The battery will generate heat. Alright, and there is battery management system. And what battery management system will do? It is trying to protect the battery from that heat. Okay, so what it will do, battery management system is trying to do, it will trying to slow down the process of movement of the ion. Okay, if process of movement of ion will get slowed down, that means the charging speed will automatically get slowed down. That's why the outside temperature will affect the battery charging speed. So how this temperature affect EV range? Okay, so suppose there is sometimes we are going driving the car and it will happen that range of vehicle will get slowed down in case of high cold weather condition. The snowfall is there or very cold weather, then it will, this is not permanent, it is temporary reduction in the EV battery range. Okay, there is science behind it due to some chemical reaction. Chemical reaction means the movement of ion. And as I told, every electric vehicle, every manufacturer, battery manufacturer, what they want, they are trying to improve the battery life and protection system of the electric vehicle. And in that case, what they have internally installed a system, or we can say the protection system of the battery, that after, if such heating will occur in the battery, then at that time the speed will slow down. Okay. Or we can say the sometimes climate control. If climate control will work in EV, then in that case the vehicle range will down. Uh, so we are interested to discuss about the how cold affect lithium ion batteries. We are using the lithium ion batteries in the EVs. So cold weather, as I told that these are having chemical or physical reactions with the battery. Those are affecting the electric vehicle movement also and the charging speed also. So here we have conductivity and diffusivity. Those are taking part in this, which will take longer charging time and temporary reduction in the range. Two things we have seen. One is the charging speed and one is the range due to the cold effect. So even not in cooling, in case of heating, if there is high temperature outside the environment where we are running the electric vehicle, then in that case also we have the reduction in both amounts, in charging speed and the range. So, but cooling is affect the these two parameters in high amount. So what will happen in this battery management system? What it should do, it should prevent the long-term damage of our battery. Okay, suppose we have high, very cold temperature outside. So this battery management system will detect this temperature and it will try to protect the battery for freezing. Okay, if it's trying to protect the battery to freeze, then also in lithium plating, there is a metallic buildup at negative mode. Those are called the anode, where energy goes during charging. So what will happen in cold weather? It makes ion flow through battery cells with a slow speed. Okay, this will build up outside the anode and turn it into a metal. Okay, this metal, what will do for future flow of energy, and it use some of the lithium that is supposed to power the battery. Okay, so single cell observation, we say, because a battery is not a uh, type of a box. It is having number of cells. Made, uh, those are combined to make a module, and different modules are combined to make a complete battery of the vehicle. So if we observe a single cell, then this can lead to a decrease in power and range. If you talk about only one single cell, but there are different cells are there, and what battery management system will do, it will try to arrange the temperature, power, and it will try to manage the power with number of cells. It is not forcing only a single cell to take the burden. So here we have a study of how electric car react to winter in very different way. Different type of manufacturers having different cars, and all cars are acting differently. Suppose this is the data winter range loss for popular EV models, and the temperature is 70 degree, freezing versus 70-degree temperature here. So we can see here the data. So up till now we have talked about the cold. Now if we have higher temperature means um, what is going on? Heating is high in the battery. So it leads to faster reaction across the board. Fast reaction means more charger, more heating will take place on the battery, and in this case also, what will do? Battery management system will try to slow down the heating process. If it will try to slow down the heating process, that means the charging speed automatically decreases in this case. Now, how vehicle decide your charging rate? Okay. So we have seen the cold temperature, what will happen in cold temperature and cold temperature. So battery management system is the brain of electric vehicle, or we can say battery management system is for the batteries only. Those are installed in the electric vehicle. So these consider some facts according to which they are uh, going to uh, change their charging rate. So they decide it by the batteries hot right now or not? Is it cold outside? Or is the battery old or deteriorated? How full is the battery? Okay. So these are some parameters. Those battery management system will observe, and according to that, it will decide the charging rate of the battery. Now, all this information, the vehicle tells the charger that is installed in the vehicle itself, the voltage and current. It can accept the product which determines the charge rate. According to that, which type of voltage it should adopt, current, how much current it should adopt. And when the vehicle start charging, it may reach the maximum charging rate up to 50 kilowatt. But the charge continues and the battery gets hotter, it will produce in there, and its cell start to fill. Okay, up till the 80% of the battery, that we call the SoC of the battery. We don't want that after 80% of the charging of battery, what battery management system will do after 80%, when it charge up to 80%, it will automatically slow down the process of charging. Otherwise, battery life will get reduced. What will happen actually, I will show in here. As I told that the battery of electric vehicle is not a complete box. It is made up of different small cells. Those we call the single battery or single cell. So here we have a single lithium ion battery in the first diagram. That it is having anode, cathode, electrolyte, and supercapacitors. This is one cell of the battery, and this many number of cells are arranged in series and parallel combination to make a module. Not only this module, the different module, number of modules are combinedly make a battery. Okay, so what will happen in the charging of the battery? On the initial state, what will happen? The ions having a loads of free space. All cells are blank. They don't have ions. They don't have charging. So ions, what they do, they can fix ourselves at any place in any cell. Okay, so they don't need time. They don't need time to decide that on which cell they have to stay. Okay, so the charging speed high, but whenever the around 70 to 80% of the cells will charge, and these cells are not charged line by line, means one line, then second line, then third line. I don't know these things. They randomly fill the cells. Okay, suppose I have the cell length after 80% charging, I have cell between 3 and 4, between 3 and 4 modules somewhere at some place. So at that time, what will happen? Ions need to decide that at which place they have the space to set up themselves. So they need to think that at which place they have the space to fix over there. That's why the speed will get slowed down. Okay, suppose here in this, I want to explore it more. Suppose in this conference room, all seats are blank. Okay, nobody is there. So one student will come here and he can sit randomly, very fast speed. He's also. And suppose in between two rows, there is one seat. So I will come here and I need to see, I need to check that where I have space, I can sit at which place. Same case in case of battery charging. So after 80%, 70 to 80% charging, I just have to decide that where I can set up myself. That's why speed will get slowed down. Okay. One more interesting thing related to all vehicles, not just electric vehicles. Here I'm talking about electric vehicle only. So why sometimes the buyers say that I'm not getting the maximum charge rate, whatever the manufacturers told me. So on these is depend upon different things. How full your battery is, means SoC of the battery, 80% charge or 50% charge. As I told you, if it is 80% charge, then after that it will have time to get charged. Okay. Then other factor is load. Okay, other loads in use while charging. Suppose I am charging on the electric vehicle AC charging station, or I am charging on the grid. If I am charging on the grid and other loads are also connected on that, that means the charging rate will get reduced. Okay, suppose I'm saying that I have only one tap of water and I am supplying from that tap of water to different consumers. Then the speed of flow less. And if I'm giving it to only one, then speed is high. Same in case of the charging station. If other loads are there, then charging speed is low. Another is battery deterioration, means if battery is new, then charging SoC is good. Then the battery can be charged with very high speed. And temperature of your battery, it depends upon the type of battery that are used in the electric vehicle. It depends upon the metallic plates, those are applied, the electrolyte that have been used on the battery. Another one is electric vehicle current and voltage limit. As I told that the power that we are getting from the electric vehicle depends upon the voltage and current. So whatever the ratings have been given to those electric vehicle or the battery specifically, then it decides the charging speed on the charging station. So on the level 2 charging, that's why we have to give a range. We are not saying that it will take 24 hours. Some electric vehicle may take 24 hours. Some electric vehicle may take only 20 hours or 15 hours to charge from the same charger. Okay. Now, if you have electric vehicle and you need to decide that on which charger you have to charge your vehicle. Okay, you have to choose the right charger. Then there are some scenarios for level 2 and DC fast charging. If we talk about level 2 charging, that means we can charge our vehicles on our home residential area or or at our offices, our universities, where we have to stay from morning to evening. Okay, 8 hours we are staying here. Then we can left our vehicle to charge on the level 2 charging station, and it can charge up to a level that we can drive it up at our home. Okay, not we are. I'm not saying that it will charge full. Okay, but it can charge. Then we can drive it safely. And workplaces and fleet overnight or high daily uses. Those are rickshaws and three-wheelers. Those are used for people. Destination shopping. Suppose we are going to a mall and we have to shop more and more from morning to evening, and we have to take some lunch over there. Then we can install these level 2 charging over there, and we can charge our vehicle. Restaurants also, schools where we are going to play sports, and also at those places we can have the level 2 charges and we can put our charging vehicles. But in case of DC charging, fast charging stations, these are of very costly, but these are most useful, um, where we have to just charge and go, like on our highways. Okay, and we are going to do a quick meeting, and we want that during that quick meeting, but our vehicle will get fully charged. Okay, emergency workplace charging or like this highway on the highways. These are fast charging stations. Our government also trying to install the fast charging stations on the already already deployed petrol pumps, okay, which are at our express highways. So EV fast charging, as we've seen that there is a lots of requirement of EV fast charging. So there are two, whether what we can do for fast charging station, whether we need to increase the size of battery in the vehicle. Okay, this is not feasible. Why? Because already our electric vehicles are too bulky, and if we increase the size of we are going to increase double the size of the battery, then there is no. And I also told that all driving forces of vehicle uh, depends upon the mass of the electric vehicle. Okay, so its range will decrease. So first method is this, whether we expand the battery capacity of the vehicle or we have to deploy more and more fast charging. The second option is better. Okay, so we need to deploy more and more charging foundations, and so we have different technologies. We have more scope in charging station deployment. Okay, starting from the forecasting of good deployment to its technologies. Have, as I told that all electric vehicles, their brain, their all their heart is the battery only. Okay, so there are some parameters related to battery that all should know. First, battery state of charge, the main thing. Battery state of charge, which decide that what is the current state of the battery and what is the rated battery SoC. So depth of discharge, how it is the reverse of SoC. State of health, the current condition of the battery. C rate, okay, which decides the time of charging of the battery. Terminal voltage, as I told that voltage and current decide the power to drive the uh, vehicle. So what is the terminal voltage and terminal current of the battery? It will also important parameter of the battery that need to be checked whenever it is going to install, and when we are going to buy or we are going to work on some technology related to the battery. And life cycle also. Okay, it is for 5 years or 4 years or 10 years. Now, what will happen? We have different parameters. So there may be battery failure. So all work is on battery in the electric vehicle. So battery failure, as I told, that battery in the vehicle is not a box, a single box. There are number of cells. So if a cell fault occurs, this may be due to some chemical reactions, change in some structure of the electrolyte. Okay, this electrolyte change may be due to some environmental conditions, some chemical process, and breakdown of the electrolyte sometimes. Okay, electrode plating or increased in internal impedance, reduced capacity, it will degrade on time. Okay, that's why we have to decide the age of the battery. And pressure that may build this pressure, these chemical changes, these are affected by those weather conditions that I earlier discussed in the slides. Cold weather. That's why we have installed the BMS to protect these type of um, cell phones only. Overheating, thermal runaway, like this. And another battery failure reason may be manufacturing process. Those are out of control. Okay, during manufacturing of the battery, there may be some degradation in that one, and aging of the battery. Suppose in the starting, what we have, SoC is good, battery is in good condition, charging is good, but as soon as time passes, there the battery will charge with a low speed, and there may be more faults occur in the battery. Then uncontrolled operating conditions, uh, these are not observable. We can't control these operating conditions. And external factors, abuse with other components. Okay, so for the protection of these faults, we have to install some protection event. Okay, and this may be battery management is all known by manufacturer, by researchers, or by the sellers of the battery, BMS. But there are more other methods also to protect the battery. What are the features of protection of this battery? The same, to uh, control the excessive current during charging or discharging. Okay, why we have to control this excessive current during charging and discharging? Because the excessive current, what will do, it will create the heat. Okay, this heating will degrade the battery. Then short circuit voltage will control, over voltage or overcharging it will control, and under voltage control DOD, depth of discharge, it will balance, and high ambient temperature it will control, overheating, pressure built up inside the cell due to different chemical reactions. Also sometimes it will do some isolation, and polarity protection it will also do. And for these features, which will cover these features, we have to adopt some protection methods. And we can broadly categorize them as thermal protection and electronic protection and polarity protection. Under the thermal protection, what we have? We have thermal fuse, thermistor, restable fuses. Anyhow, we have to control the temperature inside the battery. So we can use the thermal fuses, okay, which according to the heating, these will disconnect the charging from the cells. Thermistors we can use. With these all devices, what is it? These are sense these are used to sense the temperature in the cells. Okay. Next is electronic protection, that is battery management system. It is having different type of protection schemes, even algorithms also there. Okay, based on algorithms, we have to design the architecture of the battery management system. Then polarity protection, again having electronic components, and we can use the Schottky diode, relays, or FET or MOSFET, etc. for this purpose. Okay, this is battery management system, electronic protection. We are concerning on battery management system. Here we have different units. Here we can see the different modules of the battery. Those we called as battery packs here. And again, we have battery here. And what we have to control, we have voltage, current, and temperature. And electronic circuit here, what it is? It is battery management system which will balance this current, voltage, and temperature. Okay, to increase the battery life, to enable battery protection, as well as to ensure battery parameters, those are SoC, DOD, and aging. So, what is the need of battery management system? In electric vehicles, generally we are using lithium ion batteries, and according to those batteries here we are analyzing. So features of these uh, whatever the battery management system we are adopting, these should have some features, and these are high power density, they should have low self discharge, they should have, and the cost, this should be cost efficient, because already in the electric vehicles we have the we have to pay a high cost of the batteries. So at least the additional management system that we are going to design, we are trying to reduce cost battery management system. Okay. So, as we have seen that electric vehicle is the combination of different modules, and each module having many cells, individual cell having their individual performance parameters. So the battery management system have to manage the power distribution, ion distribution among those cells. Okay, what battery management system have to do? That the system have to monitorize the charge level of each and every cell. Which cell have been filled and which is not filled. Okay, this is the important task of battery management system in the electric vehicle. Okay, so monitoring is the main task. We have to monitor and then control the charging from fully charged cells to the blank charge. Also, these monitoring ensure safe and reliable battery operation that result in production of more efficient and safer electric vehicles. Okay, because all and all of electric vehicle depend upon its battery, and battery depends upon its battery management system. So battery management system, we can categorize depending upon the circuit we are using to design them, and the topology in which we are arranging the different electronic components, and the voltage range. We are using the battery management system for low level or high level voltages. So first is based on design. Based on design means we are using protection circuit model or we are using battery management system. Protection circuit model means we are installing some protection devices like MCBs, fuse, or relays, etc. Or battery management system, in which manner we are connecting the converters, we are installing some controllers or converters and monitoring unit, especially there in case of battery management system. And based on topologies means centralized BMS we are providing or decentralized. Centralized means we are giving only single BMS for all modules and cells. And decentralized means we are having different battery management system for different module needs. Okay. And based on voltage for low level battery management system and high level. Now, what are the functions performed by this battery management system? First is the most important monitoring function. Okay, first of all, it have to monitor that whether there is fault or not, whether a cell is empty or not, or whether is scope to more charge the battery or not. What is the SoC of the cells available? Then next is protection function. You have to check that there should not be fault anywhere. And cell balancing also. Cell balancing means suppose we don't have battery management system, then in that case what will happen, the four cell will get charged up to 100%, okay, and another cell are empty. Then this is not cell balancing. Cell balancing means each and every cell have to charge with the same level. Okay, if we overcharge the one cell, then in that case, what will happen? The cell will damage soon. It will lose its aging. Then communication means communication between the controllers, between the converters, this battery management system can do. This is a broad level task of the BMS. Then charging discharging control means, suppose charging means charging discharging control means only one cell should not have get pressure to charge or discharge completely. Okay, all cells should have the same pressure to charge or discharge. Like you all have listened this story that one stick can break easily, but more stick cannot be break easily. Same case in case of the cells in a battery. Okay, if only one cell get charged highly, then it will deteriorate very easily. Okay? So all cell have to take the burden, all cell have to charge equally, and all cell have to discharge equally during the driving of the vehicle. This is the task of battery management system. And another task is um, SOC and SOH maintenance. SOC of the battery means a single cell. If you talk about a single cell, then it should not charge after 80%. Okay, up to 80% it should charge. Then battery management system, what it will do, it will stop charging or it will slow down the charging of the vehicle. Okay. Sometimes what is the task of vehicle, we can use the vehicle as the battery storage. Battery storage means, suppose we are connecting the vehicle direct to our main grid. Okay. Main grid, we are getting the supply, we are charging our vehicle, but sometimes what we have to drive some other loads also which are connected to the grid. Okay, suppose we are not using the charge vehicle and we don't want that it will charge in its present state, because the battery may degrade if it is charged fully and it is not in use. Then in that case, what we need to do, we can supply the load with the help of this vehicle, charged vehicle. So this is vehicle to grid and grid to vehicle. Which we can talk. In vehicle to grid case, what will happen? The vehicle is charged, the SOC of the vehicle battery is charging condition, and during grid to vehicle, it is charging, and vehicle to grid, it is discharging. And discharging is not that we are driving the vehicle. Discharging in the it is driving to other loads. Okay, so we can use it as a uh, source also. So here I'm going to discuss about some research papers. Those are based on our battery management system. First is Droop control based real-time battery management system for automated DC microgrid. As I told that we can use these electric vehicles as the driving source nodes. So we can connect it to the DC microgrid. So here we need to do some real-time battery management system. So battery management system, as we told that it is the combination of electronic components which are going to control the SoC of the battery, contributing to monitor each and every cell. Here we are considering the parameter Droop control based. Okay. Here in this study, what we are going to do, we are taking the Droop control and utilizing this Droop control state of charge parameter as a Droop coefficient to maintain the charging and discharging rate of the battery. So here we have a DC microgrid and we have different energy storage units. Note one, we have different batteries are there connected. Energy storage unit means battery. We have different batteries. Number of batteries are in this microgrid, and we have to maintain the SoC between these storing units or the batteries. Okay, suppose we have 5 batteries, and what we have to do, we have to balance the SoCs of this. We don't want that only single one battery will charge fully or discharge fully. Okay, what we want to balance the SoC of those and number of storage units. Those are connected in the microgrid. So here we have this type of control. Here we have battery bank 1, 2, battery bank up to n. And here what we are going to do, we have to check their SoCs and we have controller for that one. And according to that, we need to generate the pulse width modulated signal, which is going to the DC to DC converter. And here we have home loads and we have DC. DC bulbs are connected to the this battery bank system and the DC to DC converter with the. So what we have, what is Droop factor actually? It is suppose we have a reference voltage. Suppose we have a reference voltage equation Pi. It is any set voltage V, and it is equal to a Droop SoC of the battery Pi. Okay, so what is Droop refers? It refers to controlling the output voltage with respect to the change in current by utilizing a Droop coefficient. Okay, what is Droop? Suppose I have a microgrid system and I have battery also there. So I want that I have rated battery voltage is 12 volts. Okay, and after some time, and another battery is also there. But if I am not getting that 12 volt in the output and there is 12.1 volt in the output, that change, that 0.1 is the Droop. Okay, Droop in the voltage. So we have to control this Droop, and this voltage is nothing but disbalancing in the battery. That's why we are going to maintain here the SoC with the help of Droop control. So here, if we see this VDC output, whatever the output we are getting, it is equal to, in case of Droop control, it is VDC input minus MP PP's power, and here VDC are output and input power VDCI, and what is MP here? MP and MP are the Droop coefficient. What we are saying, Droop coefficient. But in this paper, what we are going here, what we have done here, in this we are maintaining this Droop coefficient based on the SoC of the battery. In place of this current and voltage, we are taking the SoC of the battery. So here we have the output. It is equal to whatever input we are giving, and we are minus this Droop coefficient multiplied by the power. So this SoC is nothing but the current charge state of the battery to its given charge of battery. Okay, so this SoC, we have a different energy storage units here we have. So we have SoC1, it is equal to SoC1 dash. SoC1 dash is what? Initial SoC of the battery. Okay, and SoC1 is the current SoC of the battery, and it is equal to SoC1 dash minus 1 upon Cn, that is charge rating of the battery, and we are integrating I1 dt. So this is SoC. How we can find out the SoC of the batteries? Those are connected in our microgrid. Now also we know that power, it is the multiplication of the voltage and current. So here we have, and from these expression, if we put the in place of current I, and we are putting the value of current in terms of voltage and power, then we have the expressions in terms of voltage and power here, and we are integrating the power here only. So this relation is utilized here to create the Droop coefficient, and these coefficients here, M1 and M2, are the SoC Droop coefficient here. So based on the SoC, we can manage this. So during discharging of the battery, what we have, M1 is SoC1 by 100. 100 is a 100% charging of the battery. So what is SoC1? SoC1, how we can find out? That the expression that we have shown, SoC1 is equal to initial condition of the SoC of the battery, and we are including the power and voltage values in that expression. And during charging of the battery, what we have to minus that one. Okay, so we have to take the charging and discharging conditions of the battery both. So we have the power depending P1 upon P2. If we solve this, and we have P1 and P2, the power sharing is according to the SoC coefficient of the battery. So here, if we have n number of batteries are connected in a microgrid, so according to this Droop coefficient of SoC, we can balance the power. We can share the power in the ratio of their SoC. Okay. So here, this is the rough load profile taken from n number of ohms, and this is the power from PV source, that is solar source, and here we have difference of SoC battery 1 and battery 2. Okay, so what we have to do, the battery with higher SoC, if a battery having higher SoC, it have to charge with a slow speed, and the battery with lower SoC have to charge with a high speed, and the reverse will happen in case of discharging, so that there will be a balance of charging and discharging of the batteries, as well as sharing of the load between the batteries. So here we have the state of charge of battery 1 and battery 2 and their differences, and we are trying to maintain this difference to 0, so that what we want, that their SoC difference should be as low as possible. And here we have shown the difference of SoC and ratio of SoC as well as, and here we have bus voltage, and the last graph is showing the power exchange between battery 1 and battery 2. Why we are going to exchanging the power from battery 1 to battery 2? Suppose we have two batteries in the system, and if one battery is highly loaded and its SoC is going down, then in that case, what will happen? What battery management system will do? As I showed, that power is the ratio of their SoC coefficient. Okay, so according to their SoC coefficient, power will be balanced by the other battery. Okay, if one battery having low SoC. The target of this. Another one is battery control and monitoring system for DC microgrid. Okay, so here we have battery controlling as well as monitoring. So here we have to utilize a controller that is able to select the input from different batteries, and according to their state of load, they are going to select which battery have to be loaded or not. Okay, they have to monitor it first and then control. So here we have, suppose we have taken example of two homes. On the right hand side, home 1, and on the left hand side, home 2. Here we have connected it with DC microgrid bus, and we have current sensor as well, and we have battery bank 1 and battery bank 2 connected here. So what is going on? First of all, the voltage sensor to measure the voltage from the DC bus, and then it is our measure voltage, and then we have a reference voltage that should be maintained every time, each and every time, and their difference will go. If there is some error, some difference occur, that means some error. We are not getting the actual voltage that we need to get from the DC bus, so it will go into the controller. Okay, Okay, then we get the controller output and we left it here only. Then we have battery also. So from battery, here we are sensing the current, and it is the difference between battery, actual battery characteristic and the measured will have to be compared, and it will go to the controller too. Then what will happen to maintain the this voltage level? What will happen? These two controller outputs go into the minimum selector, and according to whichever is lowest, according to that, a signal will go to the pulse width modulator generator, and it will go into DC to DC converter. According to that, again, this will go into the DC bus to maintain the voltage. One another thing is what it is doing. The output of these two controllers is going to minimum selector 2, and here we have battery bank 2. It will observe the purpose of this controller 3 here and minimum selector 2 here is to decide that which home is overloaded and which home is underloaded. So the sharing between two batteries will happen here. And these are some mathematical portions of this. Suppose we have output of first controller. It is the function of error that is generated between measured and actual voltage. And the grid voltage is the reference voltage and measured voltage. And controller 2 output, it is the function of error generated in the current of battery current, charging and discharging characteristics, and the difference is based on their current only. And here we have minimum selector output. That is, minimum selector means we are taking the minimum value, whatever is. So we have to take the limit, and we have to differentiate the two functions. Okay. So here we have the charging reference current of battery bank. We can express is K into 1 minus SOT upon 100. We are showing it discharging. That's why here we have 1 minus SOT. How it is discharging, how we are supplying the load from the battery. The controller that we have used here is FMLRC. Okay, fuzzy model reference learning control. Why we are not using here the simple controller, the fuzzy controller or some PID controller. Here we need to use a controller that is having the self-adopting technology that will adopt itself according to the environmental conditions, because here we are going to connect the solar panel also, we are going to connect the public utility also. So load is also changing on the public utility, that is nothing but our main grid, and solar is the output from the solar is also changing, and the load is also changing. That's why there is need to have a controller that adapts itself according to the change in the system. So this FMLRC is working like that, and this is the model of this fuzzy reference model control. Here we have some knowledge base also. We have fuzzy sets. We have rules. Number of rules are there, and these knowledge base and rules are based on the voltage and battery capacity. And if we talk about the input of the fuzzy controller, it is according to the selector input, the difference between selector input. Change in error. If we talk about change in error, then we have to divide it by the time, according to time. Because what will happen in case of solar or the grid, the load is changing time by time, the source output is changing time according to time. That's why we have divided the change in error. In case of changing error, what we are going to divide it by the time. According to time, there is a change take place. These are the outputs of these. Here we can see that what is grid voltage, what is desired voltage. There is difference. this data is very high. That's why it is in lots of fluctuation. So here in this DC microgrid, the system that we have shown, it is having voltage sensor, current sensor, those monitors, voltage sensor monitors the senses the DC voltage bus DC bus voltage, and the current sensor will observe the battery state of charge. Okay, and here we have FMLRC, that is fuzzy controller, and it is used to adopt the changes in the system. Thank you.